Hello there, you beautiful people. So now that we've got Travis fully operational and up and running, there are a few more ways to add things to lists that I want to show you. So the first is just to use the addition operator. As we can tell, this operator has a lot of different uses. So only lists can be added to lists. So for example, if I create a list called A, and I set that equal to 5, 12, 72, 55 and 89. What that's going to do, that's going to be absolutely fine. But if I want to add the number 1 onto the end here, if I try to just type A equals A plus 1, we're going to get a type error. And that's because you can only concatenate lists with lists and not integers. Now the way that we can fix this is, well, first of all, of course, we could just use the append method that I showed you before. Or what we could do is we could type A equals A plus 1, but put the 1 inside a set of square brackets. And that is basically going to say, okay, add to A this list with just the number 1 in it. And that's going to work absolutely fine right there. But what if we want to add a string? So if I try to do A equals A plus BCD, let's say, this is still going to give a type error because you can only add lists to lists and not strings. However, because strings are an iterable data type, there are two ways to fix this issue. So first of all, we could do A equals A plus BCD and put all of that inside a list of its own. And we're going to see that you have just one element added on to the end. But the other option, so that's the first option. The other option is to use the list method. Now this is going to do something quite different. So if I do A equals A plus list of BCD, this is going to do something quite different. We're going to see here that instead of just adding BCD as one whole element, it's added B as an element, C as an element, and D as an element. So each of the elements of the string has been added as its own element to the list. Now you can't get this functionality for integers, and the reason is integers aren't iterable data types, and therefore they can't be converted into lists. So if I try to do A equals A plus list of 1, 2, 3, that's not going to work because, as it says, integer object is not iterable. But numbers are also kind of easy to work with in the sense that all we'd have to do is type A equals A plus 1, 2, 3, like that. And that would add them individually on the end. There is another trick though when you're working with numbers. Say for example, because I can't convert numbers into lists because they're not iterable, but I can convert numbers into strings. So if I did A equals A plus the string 1, 2, 3, right? That won't work because I'm still just trying to add a string. But if I convert that string into a list, so I convert the number into a string, then convert the string into a list, we now see that we get 3 strings with each of the numbers added onto the end there. So that's another potential option you might want to explore. So I thought I'd throw that in there. So let's just reset A really quick to avoid any confusion as we go forward. So A is this, and we just press enter to copy it to the next line. A equals. So what if I wanted to add a list of numbers, right? So instead of just doing A equals A plus 5, 6, 7, 8, let's say, that's just going to add them all individually. So what if I wanted to add this list as its own element? So the way that I'd do that is I'd go A equals A plus that 5, 6, 7, 8, just like we did before, but we're going to put another square bracket around it. And that is going to put a square bracket basically around that list and add it as its own element. So now it should be the final element of the list. So if I do A minus 1 to get the final element, we see that we get that list out. So that's a way that you can do that. That's how you can add in extra lists as their own elements. Alternatively, you could just use the append method to do that. So a.append the list. Let's try another one. 10, 11, 12, and 13. That's just going to add that as its own list again, you see, because I put a list inside of there. So there's loads of different ways to do these kind of things. But there is a very important issue that I want to flag up when you use the append method that can cause big problems if you don't know about it. And this issue is that the append method returns an empty value. So let me show you what I mean. If I have A, I'm just going to reset it again, just up here. So A shows up completely normal. If I do A equals A dot append 10, now if I try to look at A doesn't show up. And the reason is A dot append 10 gave back some empty space. That empty space, because of the assignment operator, was then saved in A, which basically just deleted the data, right? So if I find the type of A now, it's going to tell me none, which is another data type, but it's basically blank space. If I show you the type of A dot append 10, what is the type that A dot append 10 gives back? Well, actually, it's not going to work because I can't append anything to an empty list. So let me just make a blank list like this. Now, if I do try and find the type, it's going to tell me none, right? Because the type of whatever the append method gives back is none, and we saved that none into A, which basically deleted the whole thing. So that's something to really be aware of. Now, at the minute, I'm just showing you how you can add things to the end of lists. But what if we kind of wanted to insert something at any point in the list? Let's just make A long again. Let's make it what it was before. Okay, so now we've got our original, we've now got our original A back. Let's say we wanted to insert 100 between the number 12 and the number 72. So for that to happen, we want the number 100 to kind of be inserted here, right, and move everything along. Well, here is index 2. So what we can do is A dot insert, right? They use the insert method. We want to insert at index 2 the number 100. And if I show you that now, we can see that the insert A is inserted 100 at index 2. And you can also insert slices. So if I do A dot insert at index 2, let's say we wanted to insert 10, 20, 30, like that. We've kind of put in together, we've inserted the whole list at index 2. So that's something to bear in mind right there as well. So insert is something else that's very useful. But notice as well, I'm not typing A equals A dot insert, let's say 250 or 60. Because if I do that, now A has been deleted again, because this method, again, has returned none, and that's been saved in A, unlike string methods where you do need to do this. And the reason is lists are mutable data types, not immutable, they are mutable, which means they can be changed after you've defined them. If I had a string and I had it as 1, 2, 3, I can't change this. So let's try and turn the letter 1 into 5. It's going to give me an error. String object does not support item assignment. But if I had a list called A and I had that as 1, 2, 3, and I tried to change the first letter of A to be 5, that's possible, okay, because lists are mutable, strings are immutable. So in this insert method and the append method and methods like that, list methods, it's kind of changing the list behind the scenes, and that means you don't need to reassign A to the new value. So you don't need to type A equals A dot append 5, because if I do that, A has been, it's been turned into a non-type. Same goes for the insert method. So just be aware of those things right there. So over the last few lectures, you've now built a security system. You've learned how to combine data structures and logic by using the in keyword. And you also now know how to create lists, how to add things to lists, how to remove things from lists, which, by the way, the remove method as well, if I did A equals A, let's just make a thing called A123. If I did A dot remove 3, that's going to work fine. But if I try to do a equals a dot remove 2, again, that's also done the none. So bear in mind that all these list methods pretty much work the same. So you now know how to add and remove things from lists, how to create them, how to use them with logic, and you also know a few things to watch out for. So well done. I mean, we're pretty much there with understanding how lists work. So up next, we have Python's second type of data structure, which is called the tuple. And tuples are very simple. They basically work exactly like lists. So we're pretty almost like lists. There's a slight difference. So we're not going to spend too much time on them. But that doesn't mean they aren't important. They all have their own place. So I'll see you in the next video for some tupley goodness.